So let's review our group quiz. Find the coordinates. Coordinates means something like this. X, comma, y of the midpoint. What's the midpoint? The middle point. So if I have an end and an end, I'm looking for the middle of a segment with endpoints -11, -4, and -9, -2. So how am I going to find the middle of that? I'm sorry? There's a midpoint formula. You're right. What is the midpoint formula? Don't tell me what it is. Tell me what it does. How do you use the midpoint formula? The middle. So how would I find the middle of the x's? Let's do this. How would I find the middle of the x's? I'd find the average of the two, right? The average is add up the x's and, why did I put squared? I did that last period too. Add up the x's and divide by 2. Add up the y's and divide by 2. Alright, so my x's are -11 and -9. What is adding up -11 and -9? -20 divided by 2. And what are my y's? -4 and -2. What's -4 and -2? -6 divided by 2. So that's my midpoint. -10, -3. Conceptually. Let's do it conceptually. I'll do this over here. I'll even do it right here. Alright, so if I go from -11 to -9, that's not my rise. That's what makes this confusing. Let's do my rise first. This is my rise, correct? Is my rise? Rise is the rise? Yeah? How far is it from -4 if I were to travel up to -2? Anybody tell me? How far is it if I travel up from -4 to -2? To go from -4 up to -2. How far did we travel? 2. What would be the middle of that? 1, right? If I wanted to stop halfway from -4 to my travel to -2, wouldn't that just be up 1? Correct? Yes? Here, I'm going to put a little, this is my midpoint. Change my color. So to go from -4 to -2 is 2, but I only want to go up 1. So how far is it to go from -4 and go up 1? Where would I be at? -3. Change my color. Let's do blue. Okay, my run. From -11 to -9, how much of a run is that? How far is it to go from -11 to -9? 2. What's half of that? 1. So how far is it to go from -11 over 1? If you're at -11 and you go over 1, where are you going to be? What? If you're at -11 and you go over 1, where are you going to be? You're going to be at -10. So what I'm trying to say is that if I'm here and I have to go up 2 over 2 to get to the end point, to get to the midpoint, should I only have to go up 1 over 1? Now, I know it's hard to visualize it on here, but if you had a coordinate grid, right, that actually had boxes on it, wouldn't it be a lot easier to just count? Instead of going up 2 over 2, I would just have to go up 1 over 1, and that right there is my midpoint. That's conceptually, seeing it conceptually, not using a formula. I'm big on conceptual, thinking about what it means. So if you showed me a picture like that and gave me -10, -3, that's correct. All right? You guys did this with this one. Now in geometry last year, the way that you find the coordinates of the missing endpoint is you say, I'm not even going to go there because I did it in the last class and I lost like half of the class when I did it. But last year in geometry in the 97 standards, that's the way you teach it. If I want to know the endpoint of something, I would say, if I want the midpoint of x, I would take the x's and divide by 2. Why do I keep doing that? And if I want the midpoint of y, I would take the y's and divide by 2. Well, in this one, I don't know both the y's. See, I told you I wasn't going to do it, and now I'm doing it. Now I started that I can't finish. All right, find the coordinates of the missing endpoint R of the segment RT. So I need to make sense of that sentence right there. The missing endpoint R of the segment RT. If there's a segment RT, I'm finding the coordinates of the missing endpoint R, so this is the one I'm looking for. Given the midpoint S, so they give me S, which is -1, 5, and they give me T, which is -4, 3. I'm going to cover this. Let's do this. We'll do this one in another open window, and I'll finish this one up in here. All right. So if I'm trying to find midpoint, I find my x's, and my y's. Well, they gave me the midpoint. They gave me my x. My x is -1. So that goes here. And my y is 5. So that goes here. So it would be -1 equals, I don't know one of them. This is a question mark, right? So that would be x plus, what's my other endpoint I know? That one right there. So I have, this one is xy. I don't know what it is. So I have an x and I have a -4. And I'm going to divide that by 2. And to find the y, I know my midpoint of y is 5. And I know y plus 3 divided by 2. Now how would I solve for x and y? How do I solve this? If you have a fraction you want to get rid of it, what do? Multiply. If I'm dividing and I want to get rid of division, don't I do the inverse? I multiply. So if I'm dividing by 2, how would I get rid of division by 2? Multiply by 2. So if I were to multiply both sides of this by 2, what would I get? What would I get on this side? What's 2 times -1? -2 equals, and this works out really well because it cancels, right? And they end up with x minus 4. So how much does x equal? 2. Do this one. I'm going to do the same thing. I'm going to multiply both sides by 2. This is way too close. I have a picture under there, so I can't do anything about it. Okay. So when I multiply this side by 2, I get 10. And when I multiply this side by 2, these cancel, and I get y plus 3. So how much does y equal? 7. So what's my end point? How fun was that? Who wants to do it conceptually? I do. Let's think about it. Because are you really going to remember how to do all that? But this is the old way of teaching geometry. This is the better way? How do you know it's the better way when I haven't shown you the other way? Right? You want to see the other way? Before we judge? Okay. You know what it would really, really help is if I had a coordinate plane. Give me a second. Recording. Okay, so let's do the same problem, only you doing it conceptually, which I was really impressed many of you did. All right, so find the coordinates of the missing point. So I know my midpoint's at -1, 5. 1, 2, 3, 4, 5. There's my midpoint S. And my endpoint's at -4. 1, 2, 3, 4, 3. 1, 2, 3. Correct? There's T. So where do you think the other point is? How could I get, if I can get from T to S, can't I get from S to question mark? How could I do?
You can't get there from there.
You can't get there from there? Whoa! Okay, so count it out for me. How far do I have to rise? And then how far do I have to run? So how far am I going to rise? And how far am I going to run? Can you find that coordinate for me? 2, up, how many?
7.
What do you think? This one's easier, right? Okay, good. All right, number 3. In the figure QT bisects RQS. QT bisects RQS. All right, where is RQS? Let's look. RQS. And it tells me that QT bisects it. So, QT bisects it. What does it mean to bisect? Good, I heard the same thing, separate into equal parts. So this one equals this one? Awesome. So in the figure QT bisects RQS, I wrap my head around the picture, correct? Let's continue. It's the measure of angle RQT. Okay, hold on, pause, let's find RQT. It is right RQT. So RQT equals 6x plus 5. Let's just put blue around that one. So that blue angle equals that blue angle, correct? That's what they said, right? And the measure of SQT. Here's SQT. SQT. SQT equals this. Find the measure of RQT. Find RQT. All right. They want this right here. This is what they want me to find. I'm going to change my color. So if I have to find this, what do they want? What did they give me? They gave me 2 different angles. They said they're equal, right? So let's forget this right here. Forget these 2. I'm going to tell you that this is a slice of pizza and this is a slice of pizza. Aren't these 2 slices of pizza the same? So isn't this slice of pizza and this slice of pizza the same? Is that true? If this one's the same as this one? What are we using math to say the same? We say they equal each other. So if this pizza equals this pizza, can't I say that 6x plus 5 equals 7x minus 2? right? All right, how could I solve for x now? I've got variables on both sides. How you solve for x when you have variables on both sides? You can't solve for something when you have an unknown on both sides. You got to have an unknown on variables on one side, constants on the other. Which one's bigger? Who are we going to move? Which one would be easier to move? 6x's or 7x's?
6x's.
6x's is much easier to move than 7x's, right? So let's move 6x's then. So we decided we're going to put x's on this side, therefore we need to put constants on the other. Alrighty. So as this becomes 7 equals x, right? Am I done? Yeah, I'm done. X equals 7. What was I supposed to find? I was supposed to find this angle. What color is the angle? Blue. Well, it says that the angle is 6x plus 5. So I can say, well, I know what 6x plus 5 is because I know x equals 7. So what's the blue angle? 47. But Mrs. Muller, I plugged in the green angle and I got 47 too. How could that be? They're the same. Right? Shouldn't you get the same thing? They're both 47 degrees. They're both equal. But Mrs. Muller, my test on Thursday says that I need to find the measure of angle RQS. Uh-oh, did I say too much? What if my test said the measure of RQS? And you would add them together. If I know that this one's 47 and this one's 47, then how much is the whole angle? Right? But I didn't tell you that. Right? Please nobody put 94 on their test because the angles are going to be different, right? Okay. Alrighty. I'm just trying to say, you have to read what they're asking you to find. Sometimes they'll ask you for that angle, sometimes they'll ask you for that angle, sometimes they'll ask you for both of them put together. Okay? Questions? Alright, moving on. Number 4, find x. What are they asking me to find? X. What are they giving me? Remember what I said? Geometry. What do they want me to find? What are they giving me? They want me to find x. What are they giving me? What did they give me in this picture? They gave me this unknown angle. They gave me another unknown angle. What else did they give me in this picture? A 90-degree angle. 90-degree angles equals this angle plus this angle. That's my angle addition postulate, right? If I add them together, I should get 90 degrees. So if this angle, let's change the color of that. So if that angle is the blue angle, then we'll say the blue angle is 3x plus 2, and the other angle will make green, and that one is x. So if I add them together, what do I get? How much is 3 x's and another x?
4.
Plus?
2.
Now what do I do? When I subtract 2 from both sides, what do I get? 88. When I divide both sides by 4, what do I get? 22. What did they ask me for? X. Did I find x?
Yeah.
So that angle is 22 degrees. Questions? Moving on. What was the other part of what? What'd you ask me? Oh, I'm sorry. All right, 5, 6, and 7. Number 5, 3 points determine a plane. All right, I've got 3 points. Do they determine a plane? What analogy did I use in class? A tripod. 3 points, right? What do I do? Like this? 3 points make a tripod? So if I have 3 points in a tripod, is that a plane? Yeah, it makes a flat surface so that the tripod can stand up, right? Is there any type of defective tripod? Is there any time a tripod doesn't make a plane? Alex? If I make all of my tripod legs in a straight or collinear line, that's not a plane. That's why the tripod falls over. So this is sometimes true. Let's try the next one. Points X and Y lying in plane R. So what should I draw? I'm going to draw R. I'm going to draw a plane. What did it tell me about R? What did it tell me about R? Points X and Y are in there. Do you guys remember that other analogy about, I forget exactly what I said, if I'm wearing a shirt and I go in this room, then the shirt goes in with the room with me, right? So if you've got 2 points, what do 2 points make? 2 points make a line. That's what they're getting at. 2 points make a line. So it says points X and Y lie in a plane. Therefore, the line that those points are on are also in the plane. If the points are in the plane, then the line has to be in the plane, right? Okay. So points X and Y lie in the plane. Any point collinear with X and Y is in the plane. Let's think about collinear. So if I have a point that comes along, let's call it Z, and it lands on that line, is Z in the plane?
Yeah.
Always. Right? If there's 2 points in a plane and they make a line and we identify another point on that line, then that point must be in the plane too. Right? It's just like saying if I had a shirt on and then we're going to talk about my socks, aren't my socks also in the room also?
Yeah.
As long as I'm wearing them, right? Okay. There are at least 2 lines through points M and N. Okay, so we're talking about M and N. What do we know about M and N? And 2 points make up a line. And this one says there are at least 2 lines through these 2 points. Why? Are there at least 2 lines? I know there's at least 1 line. Is there at least 2? No. No, there can't be at least 2, right? Because if there were 2, they'd be the same line. Correct? You could have another line coming through one of the points because they intersected exactly 1 point, but you can't have 2 because they'd be the same line. That's why the definition says there is exactly 1 line through 2 points. That's not a line. A parabola isn't a line. Right? It's a U-turn. Okay. So this one is never. How are we doing? Any questions so far? How are we doing? Good? All right, so draw the image of the figure into the transformation. X comma Y changes into Y comma negative X. What happened? Tell me what happened. What happened with this transformation? The X and the Y switched places, and then what happened? the x, not just a negative, but an opposite, right? Okay, so I'm going to use color, because color rocks with this stuff. Let's start with this one. So that points at, what is that, -3, +3? After my transformation, what's that going to change to? So what becomes the x? I'm here. Oh, that's what you guys are yelling at me about. This is smaller, you're wrong. Okay, are we better now? Okay, now what? Now it's 4 and 3, because the -3 goes into the y position and it becomes the opposite. That's why we don't say it becomes negative, because it was negative, and so now the opposite is now positive. So 4, 3 is right. 4, 1, 2, 3. There's the blue one. Switch to red. So -4, 1. -4, 1. What's that going to change to? 1, comma, 4. Good. 1, comma, 1, 2, 3, 4. And purple? This one next? What's this one? Okay, so we changed our color to purple, and so let's do this one. -1, 4. -1, comma, 4. So, apply the transformation. What's the first coordinate going to be? 4, comma, 1. 4, comma, 1. And the last one, let's do green. 0, 1. So what's that going to transform to? 1, 0. And then we connect the dots. Isn't it pretty? And informative, right? Okay, name the transformation. I'm sorry, any questions on that one? No, pretty straightforward. Okay, name the transformation and use coordinate notation to write the rule. What type of transformation is this? Some of you said slide. I let you slide on that one. I'm not going to let you slide on that one again. What should you call that? A translation. All right, so this is a translation. Let's write the rule. Okay, you could count and plot all of these, right? Write the coordinates out, see what happens to them, or somebody who is thinking about it conceptually would just look at it and count. How far does it get from J to J prime? How far do I have to rise?
1.
And how far do I have to run?
3.
So I have to rise in the positive direction, and I have to run in the negative direction. So what's happening when I'm running? X what? -3, and what's happening as I'm rising? +1. Or you could have written all the coordinates out, looked at the relationships between them, right? What's so funny? Everything. Is this a lot easier than some of you did it? You're trying to compare it. Sometimes it helps to just, like, think about what's happening. Right? How much is it shifting? It's shifting up 1 and over 3. Just count. And I would be careful. I would say I'm rising 1 and I'm running 3 in the negative direction. Rise has to do with Y's. Rise, Y's. Like that. And I got nothing for run. It's just X. Or skies and taxis. Okay. Moving on. Use coordinate notation to write the rule that maps each pre-image to its image, then identify the transformation and confirm that it preserves all lengths and all angle measures. Okay. Lot to do on this one, right? So what's it asking me? What's it giving me? It is asking me to use coordinate notation to write a rule. I need a rule. So my rule looks like this, right? So I don't want to forget. Then I need to identify the transformation. Identify the transformation, and then see if it preserves all lengths. I'm not going to do angle measures because once I mapped this out, I realized it was so small that it would have been cruel to ask you to measure those angles. That, as we'll learn later in geometry, if all three sides are the same, then the angles are also going to be the same. Okay? So all that was really important to me is that you measured all three sides. Okay. Let's get to work. So negative 3, 2 would be right here. That's A. And negative 4, 3. There's B. And negative 6, 2 is C. So there is my pre-image. Now I'm going to do my image. What color? Red. Blue? I like blue too. Let's do it. Let's do red. I'm already on red. A prime, negative 3, negative 2. Negative 3, negative 2. A prime. B prime, negative 4, negative 3. And C prime is negative 6, negative 2. This is a, what? A reflection. Over what axis? It's over the x-axis. What do I know about reflections over the x-axis? The y changes. The x stays the same and the y goes opposite. Or you could just look. Negative 3, negative 3. X stays the same. Negative 4, negative 4. X stays the same. Negative 6, negative 6. X stays the same. What happens to the y? Becomes the opposite in each one of those, correct? So I'm almost done. Last thing I need to do is measure. Well, since I've got my picture already done, can't I see that A, C, why did I put C way out here? It's like floating. Okay. I already see that AC and A prime, C prime are the same, right? Can you see that? So what is AC? Distance of AC. Measure of AC. 3? And what's A prime, C prime? A prime, C prime is also 3. That was easy. Let's measure AB. Now I can either measure AB by looking at the distance between negative 3 and 4, or I could look at AB and measure, how do I count that? Up 1 over 1? So isn't that just, no. It's the rise squared plus the run squared, right? Which is square root of 2. Correct? Change in y, change in x. What about A prime, B prime? How do I get from A to B? 1 squared, 1 squared? 1 squared plus 1 squared equals the square root of 2. What about what about BC? If you don't like counting on here, you can always count here, right? X is, how far is it from negative 4 to negative 6? 2 squared. Or you could have looked at it. From B to C, isn't that 2? How much is the rise? Let's see, how far is it from 3 to 2? I'm hoping this is starting to solidify a little bit. Are you guys liking the counting thing rather than the x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared? This one? What's 2 squared plus 1 squared? Square root of? And guess what this is going to be? It's going to be the same thing. From B to C, got to run 2 and rise 1. So that would also be 5. And that would give you full credit on this one. 5 points. Oh, what am I missing? I just got 4 out of 5. Uh-oh. Good thing we had extra credit, right? I forgot the transformation. What's the transformation?
Reflection.
It's a reflection. Alrighty. Questions? Okay. Good job, guys.